All right, now on to the rest of them. Boom, boom, boom. So we've already figured out number 1 and number 2 were both divergent. The first one by the limit comparison test, the second one by the ratio test. And what I've written for number 1 and 2, that's all you have to write on your test. You just better be right. And if you make a mistake, you get no points of partial credit because there's nothing to work off of. Because really, the work is just to check to make sure we are correct. So we know we've already gone through those. So now we're going to start thinking, all right, let's use the alternating series test on number 3. This was our guess. So what do we do with something like that? How do we deal with the alternating series test? Oh yeah, AST is not so bad. So for number 3, if we want AST, we got to make sure it's non-increasing. And we need the limit as k goes to infinity, the absolute value of a sub k to equal 0. And if both those things are true, then gosh darn it, that thing is going to converge. Well, to tell you the truth, I wouldn't do anything. I'd just be like, dude, that thing converges. It's not increasing, and yes, that limit's going to go to 0 when you take the absolute value. I mean, and when we're talking non-increasing, we're talking about for the absolute value of a sub k, not for the whole thing. So we look at the absolute value of a sub k, and we're like, it's 1 over, yeah, it's 1 over 3k plus 1, but we really should be looking at the sum. My bad. I'm not even going to write in the, well, no, let's go. K equals 1 up to infinity, k equals 1 up to infinity. Dude, that thing is decreasing. Look, the k's are on the bottom. The denominator is getting bigger and bigger. So it is decreasing. So we have found it's non-decreasing. And now we just want to take the limit as k goes to infinity of 1 over 3k plus 1. And we're like, bro, that thing goes to 0. Therefore, it converges by the alternating series test. So we found out this one converges by AST. Done. Done, done, done. Alternating series test, not so bad. You're going to find it with those negative 1s to the k. That doesn't always mean it's an alternating series test that you're going to use. We can use those for ratio and for root. But it's a good place to start recognizing the different types. Don't want to get rid of all this nonsense. So let's start looking at number 4, which we have assumed to be a geometric. Possibly. We're going to find out if we're wrong. We might need to make some moves here. See what's going on. So we want to change this thing up. We want to get it set up in the form where we can get what the a is and what our little r is. So up top, this is 3k times 3 to the negative second power. Down below, this is 4k times 4. So this is actually, well, let's just write it in, k equals 0 up to infinity. This is 3k over 4k. This is 3/4 to the k. And that 1/9 right there, we need to bring that down below. We get 1 over 36. Therefore, our a is 1 over 36. Don't give a shit about that. But our r is equal to 3/4, which is clearly less than 1. Therefore, this converges by the geometric series. I'm just going to call it geo. Converges by geo. So we found out it converges. Sweet, we're halfway done. See, alternating series, not so bad. Geometric, not so bad. Ratio, root, yeah, ratio can get to be a pain in the ass. Remember that. Ratio test? Oh, ratio test can get brutal. All right, especially with those factorials. And if we don't understand what a factorial means or how they behave, we are screwed. I like that. I like to get things right. I like to know what's up. Okie doke. Number 5. We're thinking it's root. We're thinking it's root. So, okay. What do we do with the root? What do we do with the root? Oh, yeah. Don't we just take the kth root of whatever, or the absolute value of our a sub k is? Well, we don't need an absolute value because that thing's already positive. And, oh, we don't use the sum. Oh, dude, I'm sorry. We take it and we just use the limit of it. And if this thing is 0 up to 1, we converge. If it's 1, it doesn't tell us anything. And if it's greater than 1, it diverges. Well, come on, man. Come on, man. Just to start this frickin' problem, which grows faster, k or the exponential function? This thing will converge. It better frickin' converge. So let's put it in. We're like, all right, so it's the limit as k tends towards infinity of the kth root. I'm going to write it as 1 over k. If you don't mind, it's the same thing for k and 2 to the k. Let's bring it into both terms. So we get k to the 1 over k. And then we get 2. Then we get 2. So this is 1/2 times the limit is, don't write x, k goes to infinity of k to the 1 over k. Now, in the interest of time, if we do L'Hopital's on this, we've done this before. This is in a previous video. I think it was actually in the last one in 10.7. I'm jumping to this and saying this is 1/2 times 1. The limit is k tends towards infinity of k to the 1 over k is 1. So this is equal to 1/2. And 1/2, well, shoot, that's trapped in between 0 and 1. Therefore, this converges by the root test. Done. So we converged. Three more to go. We got a comparison test. We got a, oh man, these aren't bad. These are going to go quickly. I'm telling you, these are going to go quickly. Comparison test, we just got to make sure we compare in the right way. And I know a lot of us get a little wacky. Get a little wacky. So let's start with it. Bigger denominator means smaller number. Smaller denominator means bigger number, right? Because we're only dealing with positive values of k. Well, that one's actually dealing with 0 to start off with, but who gives a crap? So we want to compare it to something. So I think, let's say our a sub k is equal to 1 over k squared plus 1. And maybe we could say, what's something that's going to be bigger than it? Because I'm thinking, there's a 1 up top and there's k's in the bottom. I'm guessing this is going to converge. I have a big guess this is going to converge. So if I want something to converge, that means I have to find something bigger. And if I can show that something bigger than our a sub k converges, then, well, since k sub k is smaller, well, shoot, it's going to work out great. So I'm going to claim that something bigger would just be 1 over k squared. Yeah? So if we can take this sum in blue, we're like, well, wait a second. K equals 0 up to infinity. Oops, that won't work. I got to use a 1 here. Sorry. I screwed up. I got to start with a 1. I don't know why I wrote 0 in there. Muy malo. Very, very bad. That wouldn't have worked if k started at 0. We wouldn't be able to do this. So, there we go. It's got to start at 1. That's your teacher's bad. So we go to here, and we're like, well, that converges. Why does that converge? By p-series. It converges by p-series. Therefore, since 1 over k squared is a larger sequence than 1 over k squared plus 1, all the values are going to be larger. Therefore, something smaller must also converge. So, therefore, it converges. Therefore, the sum from k equals 1 up to infinity of 1 over k squared plus 1 converges by the comparison test. So when I said this converges by p-series, that's not saying the whole thing converges. It just says that one little comparison that we used converges. But the logic to use the comparison test, that's actually what we use. So we can say it converges by the comparison test. And then we have our last two. I'm feeling good about this. I know I can integrate number 8. And I've seen number 7 so many gosh darn times now. I'm pretty sure divergence test is going to work fine. Now, the divergence test is as simple as just taking out the sequence inside the sum and taking the limit. And if it doesn't go to 0, it diverges. But this is equal to, have you seen this enough times? K over K plus 1 over K. K over K is 1. This will go to 0. So we have 0 plus 1, which is equal to 1. 1 does not equal 0. Therefore, we diverge by the divergence test. Well, do you think that we could have found out through the divergence test that it converged? No, it's called the divergence test. It shows if it diverges. So we already knew. If we're choosing that to be a divergence, it's because we should look at it already and go like, hey, I've seen this pattern too many frickin' times. That clearly diverges. Yeah. Yeah. So there's those. And then lastly, we got our integral test. So we got to check a couple of things. We got to make sure it's always positive. Well, our k is starting at frickin' 3 on number 8. K will be positive, ln of k will be positive, and it's going to be squared, so it doesn't make any frickin' difference. Now, is it decreasing? Hell yeah, it's decreasing. All the k's are in the denominator. It's just getting bigger and bigger down the denominator, making the whole thing frickin' go. Now, is there anything else we need to check? And I think that answer is yes. It's saying that if we want to take this and convert it into an integral to do the integral test, this needs to be continuous on the interval from 3 to infinity. Well, we'd have issues at x equals 0, because that would make a discontinuity. We'd also have an issue at 1, because ln of 1 is 0. So that would be, but we're starting at 3. So let's do our integral test. So if we can find that this is going to go to some sort of value, then we're good to go. So let's write this thing out. Let's be all proper. Let's call it the limit as b tends towards infinity, because infinity is not a number. And we have 1 over x times ln of x all squared. Decided to write it a little bit different. But when the square is on the word or the ln, just like with trig, it means the whole thing is being squared. So let's go. U is equal to ln of x. du is equal to 1 over x dx. There it is. There's our 1 over x. There's our dx. We good to go. So now, excuse me, limit as b tends towards infinity. We have this. We're at 1 over. So we lost the 1 over x dx. Oh, so this is just going to be u squared du. Chill. We got this thing. But now we got to change our bounds. I'm still leaving this as b. ln of infinity is still infinity. Spoke that incorrectly. And now we need to take our, now we need to take our 3 and pop it into there, and we get ln of 3. Cool. Well, let's solve said integral. I'm going to write it differently and just call it u to the negative second power. That's going to make life a lot nicer for us. So its limit as b tends towards infinity of, so we're going to add 1 to that exponent, u to the negative first. We're going to multiply by negative 1. Or I'm sorry, we divide by negative 1. My bad. Such a dick. And here we go. So we're going to get negative 1 over u. Oh, wait. Let me write this. I'm being a little improper. Sorry, I'm getting excited. The section's finally done. Feels like we've been here a while. And if it feels long for me, how could it feel for you? So we're going to get negative 1 over b minus negative 1 over ln of 3 with the limit as b tending towards infinity. So whack, that goes to 0. So it looks like this turns out to be 1 over the natural log of 3. And since 1 over ln of 3 is a finite number, it's less than infinity. That means that we converged. We converged by the integral test. And there it is. We've run through. We've done 8 of them. 8 different problems. Now, if you start looking through here, there are multiple different things we could have chosen. We could have chosen many different ways of through it, but I don't know whether they'd all have worked, so we use something different. Down here at number 6, this is also the integral test we could use. We could also use the integral test on it. It's definitely, that's an integral as well. This guy up here, number 5, we chose the root test, but you could have also used a comparison. Could use the comparison test there. Could have called that 1 over 2 to the k. Could have compared it to something else. Actually, no. I think we'd have to compare it to some other different. But that would have got a little tricky. Did you know you could also do this with the integral test? Yeah, it's always decreasing. Always decreasing. It's continuous. Yeah. You could have done the integral test as well. So there was 3 different options for number 5. There was 2 different options for number 6. And then the rest of them, I don't see another option. I think those are pretty much it. So here's the game. So we'll have a worksheet for you to do. Hopefully you already have that in your hand if you're watching these videos. Or maybe you're just one of those nerds that likes to get ahead. Good for you. But yeah, you'll get some more practice before you do it on a test. And if for some reason you're taking an exam and you're like, dude, I can just solve them all by this one method. Solve them all by the method. Don't leave something blank because you can't find something new that doesn't match. Like I said, it'll be a small penalty. It's not going to be the end of the world. You're not going to fail your test because you used one of our convergence tests twice. But there will be a small slap on the hand because the game is, I want you to be able to differentiate the 2, or the 8. Now, number 2, that might be a little much for a test, but I wanted to show you the 2K. All factorialed. So we'll try and keep them pretty mellow on an exam. So it's your job to be able to recognize these 8 different methods of seeing whether a series converges or diverges. All right, I'm done babbling. I think I'm going to go play some video games for the rest of the day. Huh? I think that sounds nice. All right, I'm out of here. Late.